Hello everyone, welcome to the third chapter of this ArgoCD tutorial series, and in this chapter we are going to cover the ArgoCD architecture, and then we will also deploy a sample application and then see what is going in the backend of all the ArgoCD components, and that will give us a clearer picture of the components of ArgoCD. So basically on a high level, ArgoCD has 7 components, but in this architecture you can see the main ones are these 3: API server, repository server, and then application controller. So basically the API server is just like the Kubernetes API server. It exposes the API to be consumed by web UI, CLI, CI/CD systems, etc. And it's basically responsible for coordinating the communication between the other ArgoCD components like repository service, application controller, application set controller, etc., which we will dive into in a little bit. So the main responsibilities are application management, invoking of application operations like syncing, rollback, and some of the RBAC management, etc. And also it is responsible for authentication and authorization. Next is repository service, and this service is basically responsible for maintaining a local cache of the Git repository that holds your application manifests, right? So for example, in your ArgoCD application manifest, you will have repositories URL, which will be your GitHub repo URL, then revision, which will have commit, tag, branch, etc., application path. And then what it does is it generates and returns the Kubernetes manifest when provided with all these following inputs. We will dive into the application object in a little bit, but this is what the repository service is responsible for. And then we have a controller. There are other controllers as well called application set controller, etc. But application controller is a controller which is responsible for maintaining the current state with the desired state which is in your Git repository, right? So we took a look at the ArgoCD and the GitOps principles, etc., where one of the principle was the desired state should match the current state, right? So the application controller continuously monitors the running application and compares the current state against the desired state which is specified in the Git repo. So whenever it detects an application which goes out of sync, it takes corrective action, which means it will just go ahead and then reconcile or run that reconciliation loop and then bring it back to the original state or desired state which is defined in Git. So these are the things that you're seeing in the architecture diagram, but let me dive deeper into some of the other components. So in the previous section we installed ArgoCD and then we did a bunch of ingress configurations, DNS configuration to expose it to so that we can access it using a URL. So here as you can see, I'm logged into the ArgoCD console, and if I just go ahead and do kubectl get ports in the ArgoCD namespace, you'll see that basically these are the 7 components which are responsible for all the magic which ArgoCD is responsible for, right? So for example, we already discussed about application controller. We have another controller called application set controller. So earlier we had something called application of applications pattern, where we tried to deploy one application to multiple ArgoCD clusters. Now application set takes that and builds it natively rather than creating your own patterns. So what this does is you can deploy multiple applications across multiple ArgoCD clusters by just defining in the application set object or manifest, right? So it has a separate controller for it. It was not earlier there, and it is a relatively new controller, but this simplifies a lot of things. So we'll dive deeper into the application sets, various types of application sets in the future sessions, but this is the job of application set controller. Then we have Dex server, which is responsible for single sign-on from GitHub, SAML, Microsoft, LinkedIn, etc. Then we have notifications controller. As the name suggests, you can have notifications sent to Slack, anything else, any notification channel. Redis is for caching. So basically your GitHub repos that can be cached so that it doesn't have to again go there and fetch everything. Then we already talked about repo server, and then this is the API server. So what we'll do is we'll do one thing so that we understand this architecture a little better. So I've already gone ahead and prepared this simple application. What it does is it basically deploys a Nginx application and then it just exposes it using a load balancer. Now it's a very simple thing. It's not a Helm chart, etc. But as you can see, what I'm trying to demonstrate here is ArgoCD working, and also how the various components come into picture whenever you do a deployment. So I'll go here, and I'm doing this through console, but we'll dive deeper into how to create a manifest files, etc. But I can either click on this new app or create application, type in my application name called, let's say, ArgoCD sample application, choose the project name. So project name is basically, it's a logical separation that we do. So for example, you will have multiple teams in an organization, right? And each team might have the requirement, to segregate their workloads in separate projects. So what you do is, so for team A, you will create a project as team A, and then for team B, you will create project as team B, and all the team A's workload will be in team A's project, right? So that way you will have clear segregation. Or that's the functionality of this project, and this is also managed by the application controller. There's no separate controller for that. Now by default it comes with default, so I'll just use this. Sync policy, manual, automatic, doesn't matter at this point of time, but I'll dive deeper into sync policy, sync options, etc. in future sessions. Let's choose the repository URL. So what I'll do is, this is a public URL, so you can also go ahead and then just copy it and then use it. So let's go ahead, copy it. I'll keep it as main branch or head, and then I'll type the path as this particular thing. So you can find all the resources of this entire tutorial series in this repo. I'll paste the link as well in the description. But this will be my path, and then destination is basically the cluster name, and then let's choose the default namespace. So this is the cluster where ArgoCD is installed. I have not connected any other clusters at this point of time, but we will do that in subsequent sessions. So what I'll do now is just go ahead and then create. Now one cool thing is you can go ahead and then edit it as YAML, and this is what an application object looks like, right? And this is the server where it will be deployed. This is the repository URL, this is the path, this is the target revision, and all those things. So there are many other parameters as well you can pick, like swing policies, right? Now what I'll do is I'll just cancel out of this and then just hit create. And what it'll do is, so since it is a public repo, it will directly go ahead, it will have access and then pull the deployment and service and then just go ahead and deploy it, right? And since I chose the sync policy as manual, I'll have to click on this sync button, right? If I would have chosen automatic, then it would have automatically done that, right? So we'll discuss about sync policy in future sessions, so let's not worry about that at this point of time. But here I just wanted to show how the various controllers are coming into picture in the backend. So let's go ahead and see what's happening in the backend, right? So if I do kubectl logs, and I know that since it was an application object, the application controller would be responsible for handling that. I'll just check the logs of that, right? So yeah, I should have trimmed it, but as you can see, some of the configurations here is, it's going ahead and then let's see from where it is starting. So refreshing app status, comparing app state, right? And then it's just saying, okay, it's out of sync, and then the application name, the destination namespace, which I chose default, and then it just says, okay, it was missing, and then it starts the sync, right? And then it keeps on checking that, and then it applies the service, it applies the deployment, and it says, okay, now everything is good, right? So this is what is happening in the backend, right? And you can also take a look at the logs of other objects as well, but I'll not dive too much deeper, but you get the idea what is happening in the backend, right? When you deploy something, the application controller comes into picture, picks everything from the repo and then, you know, tries to compare it, whether it is already deployed, not deployed. If not, then it matches the desired state with the current state if there is anything which is missing. So for example, let me do something like this. So if I say kubectl get pods and default namespace, I'll see that there will be a pod, right? So let me go ahead and do this kubectl. Let me do this get deploy. And since you can see there are two replicas running, what I'll do is kubectl edit, and then I will do deployment and my app, and let me go ahead and then change the replicas from 2 to 1. As you can see, that's done. And if I just go to get pods, you'll see that, you know, one pod went away. Now this thing which I did it out of band of ArgoCD, right? So if I go to the ArgoCD console, you'll see that it'll say out of sync, right? And why it went out of sync? Because I did something which is I made the replicas from 2 to 1, or I reduced the replica count from 2 to 1, right? So that is what it is complaining about. And what I can do is, since the sync policy was manual, I just wanted to show you, right? So that otherwise it would have just done it and we wouldn't have seen it in action, right? So this is what you can see, scale down replica to 1 from 2, and that's what it is saying, that okay, it is out of sync. Now what I can do is I can just go ahead and hit on synchronize, and you can see that sync is running. And if I come here and then go to pods, you'll see that, you know, automatically the deployment, it would have again said okay, the replica should be 2, because in the GitHub repo the defined or desired state is 2 replicas. If I will change something here, that will become my desired state, and then you know, the current state, then it will match. So ideally, if I have to change the replica from 2 to 1, I should have done from here. Then ArgoCD is tracking this as the desired state, and then it will match the you know, the replicas over here. I can show you, it's straightforward. So if I just go here and okay, I'll have to sign in. We do that. Okay, I'm signed in now. Now let me quickly go ahead and then edit this to replica 1, and then I'll do the change. Now as soon as I do this, and if I just do and, you know, maybe hit refresh here, right, as you can see that you know, it's again out of sync. Now ideally what should have happened is, so I clicked on this refresh to, you know, make sure that it has the latest desired state from Git. Now that time limit is 3 minutes, and I know I am diving too much deeper, but every 3 minutes the desired state is checked, right? So if I have to short circuit that, I have to click on this refresh or change that time from 3 to maybe some seconds. Now again it says it is out of sync, and let me click on this sync, and if I synchronize it, you'll see that, you know, it's synchronized, and then it reduced the number of pods. Now if I go to the console again, and now this time if I do deployment, now you can see one by one, and this is the desired state because this is what we mentioned over here. So we covered what the various components are of ArgoCD: API server, repository server, application controller, application set controller. We also looked at some of the other components like Redis component, the notifications controller, Dex server for SSO, etc. And we also deployed a simple application and then saw how the application controller is behaving in the backend. So hope you like this video, and in the next video we will dive deeper into application set controller, then the various sync policies, pruning policies, and then we will also look at some of the performance tuning parameters of ArgoCD. So stay tuned and see you in next chapter. Thank you.